here we have going to solve these examples. Find the domain of the function f of x is equal to x square plus 3x plus 5 upon x square minus 5x plus 4. Okay, when we are going to find a domain, we have to check it is a function of a type rational function. Okay, it is a polynomial upon polynomial form, f of x upon g of x. Okay, so here we have to check the denominator should not be equal to 0. For which value of x it is 0, so it will be not contain it in its domain. Okay, so we have to check here x square minus 5x plus 4 not equal to 0. So for that we have to find the factor of 4, which will give us minus 5 value, which is 4 into 1. 4 plus 1 is 5, but we required minus, so we take minus 4 minus 1. So it can be factorized as x minus 4 into x minus 1 equal to not equal to 0. Okay, we have to find the values which are not equal to 0. We consider it as equal to 0. So we can write x minus 4 equal to 0 and x minus 1 equal to 0. So we get two values, x is equal to 4 and x is equal to 1. X is equal to 1. For these two values, our denominator is 0. So that these two values will not contain its domain set. So our domain set will be domain of f is or will be belongs to R minus all remaining values, real numbers will be present in domain except 1 and 4. Except 1 and 4. Okay, this will be our domain set. Now next example is the function f defined by f of x is equal to 1 minus x for x less than 0 is equal to 1 for x is equal to 0 and x plus 1 for x greater than 1. We have to draw a graph of the function f of x. Okay, if you check the types of the function, I think it is of the type signum function. Okay, so here we have to draw the graph. We first take some values related to this x. Okay, so here for x is equal to 0 it is 1. We will check for negative values of x and positive value of x. So for f of minus 1, so f of minus 1 is x less than 0. Okay, minus 1 is less than 0, which will satisfy this condition. So 1 minus of minus 1, so it will be 1 minus x. Function f of x will be 1 minus x. So 1 minus of minus 1 is equal to 1 plus 1 is equal to 2. Okay, here x is minus 1, so we take here a function f of x is equal to 1 minus x. Okay, because it is in condition x less than 0. Next, f of minus 2, again it is here you can write minus 1 is less than 0, so we are taking this function. So next it is 1 minus of minus 2 is equal to 1 plus 2 is equal to 3. f of minus 3 is equal to 1 minus of minus 3 is equal to 1 plus 3 is equal to 4. Okay, f of minus 4, it is 1 minus of minus 4 is equal to 1 plus 4 is equal to 4. Okay, so these are the values of x less than 0. Now we consider for x greater than 0. So for f of 1 for x greater than 0, here we have considered for x less than 0. So now for x greater than 0, 1 is greater than 0. So here we take f of x is equal to x plus 1. So we can write f of 1 is equal to 1 plus 1 is equal to 2. Okay, next f of 2 is equal to, here it is function for x greater than 0, f of x is equal to x plus 1. You can write here also, you can take f of x is equal to 1 minus x, so that you can do the calculation. Now for f of 2 it is 2 plus 1 which is equal to 3. For f of 3 is equal to 3 plus 1 which is equal to 4, and f of 4 it is 4 plus 1 is equal to 5. Now when we are plotting the graph, you have check what are the values related to the function value x. Now here we have given for value of f of x is equal to 1, for x is equal to 0, so that for 0 it will be 1. Okay, now for positive, for 1 it is 2, for 2 it is 3, for 3 it is 4, for 4 it is 5, and for 5 it will be 6 here, and so on. Okay, and for left side, if you consider the graph, for f minus 1 it is 2, so minus 1 it is 2, for minus 2 it is 3, for minus 4 it is 5. Okay, so we draw the line through that points. Okay, so this part in first quadrant, it is function f of x is equal to x plus 1, because in this it is x greater than 0. Okay, and second quadrant, it is a function f of x is equal to 1 minus x. Okay, here x is less than 0. Okay, so this is a graph of a function f of x is equal to 1 minus x for x less than 0 is equal to 1 for x is equal to 0, and x plus 1 for x greater than 1. Okay, so in this way we can draw a graph of any function. Now consider the next example. Let R be the set of real numbers. Define a relation f from R to R by f of x is equal to x plus 10 and sketch the graph of the function. Okay, now here the function given is f of x is equal to x plus 10. Here variable is x, and if we see the degree of x, here it is 1. Degree of x, here equation is x plus 10 and its degree is equal to 1. So this type of equation is or this type of function is known as a linear function. Okay, in general it is of the form f of x is equal to mx plus c, where f is a function from R to R. Okay, now to draw such type of a graph, or we have to draw a graph for a linear function, you have to remember that the graph of any linear function is always a straight line. Okay, now when we have to sketch the graph of a linear function, you have to only need to find its x-intercept and y-intercept. That is, this line x plus 10, we have to find its line cutting at x-axis or intersecting at x-axis and intersecting at y-axis. Okay, that what only we have to find. Now if we consider the f of 0, that is for f of 0, its value will be 0 plus 10, which is equal to 10. Okay, so for x is equal to 0, value of y is 10. Okay, and for we have to find a value such that it will be 0, function will be 0, so it will be minus 10 plus 10. Okay, minus 10 plus 10 is 0, so it will be f of minus 10 is equal to 0. That means for a value of minus 10, its x value is 0. That means we have find its x-intercept and y-intercept. Okay, so this is our x-intercept, 0, 10 value is y, so here it is y-intercept, because x is equal to 10 and we have f of x is equal to x is equal to 0, we get f of x is equal to 10, means y is equal to 10, and here x is equal to minus 10 and y is 0, so it is our x-intercept. Okay, so when you are drawing graph, you have to draw a line passing through these 2 points only. Now here first y-intercept is 0, 10, so it should be on a y-axis. So it is for value of 0, x is equal to 0, y is 10, so it is our first point, 0, 10. And for second x-intercept, it is minus 10, 0, for value of x it is minus 10 and its value of y is 0, so it is our x-intercept. That is, on x-axis value of y is 0 and on y-axis value of x is 0. You have to remember this. Okay, this is a point denoted by minus 10, 0. You have to remember that on x-axis y values is 0 and on y-axis x is 0. Okay, this is important part when you are doing plotting on a graph. Okay, now we have to draw a line passing through these 2 points. So this is a graph for the function f of x is equal to x plus 10. Okay, this process is done for only linear functions only. Okay, which x variable with degree 1. Okay, so this is a graph for the given function f of x. Okay, now we consider next example. If f of x is equal to x square, find f of 1.1 minus f of 1 upon 1.1 minus 1. Okay, here we have given a function f of x is equal to x square. So now we find f of 1.1 first. F of 1.1, that is we have to put x is equal to 1.1 in this function. So we will get 1.1 bracket square, and 1.1 square is, when you calculate it is 1.21. You know that 11 square is equal to 121. So here it is 1.1, which means we have a calculation 1.1 into 1.1. So we have to shift a decimal from right to left. Here it is value after decimal it is 1, and here after decimal it is only 1 value. So we have to take a point from right to left. 1 plus 1 it is 2, so here we have take 1.21. If we have given to 0.5 square, so 5 square is our 25. Okay, now it is a calculation of 0.5 into 0.5. So after point there is only one unit, one number, and here so we have to take a point in this number. So we have from right to left we have to take a point. So 1 plus 1, after here it is one number, here after point it is one number. So 1 plus 1 is equal to 2 number. Okay, when you have done a calculation of 0.5 square, we have to take a decimal from right to left after 2 digits. So 1, 2, after 2 digits we take a decimal. So 0.25 is a square of 0.5 square. Similarly 1.1 square is 1.21. Okay, next f of 1 is equal to 1 square. 1 square is 1. Okay, now we have to find f of 1.1 minus f of 1 divided by 1.1 minus 1. Okay, we put the values. 1.21 minus 1.1 is 1 divided by 1.1 minus 1. Okay, so 1.21 minus 1, 1.21 minus 1, it is after, here it is only 1, after point you can take it as a 0. So here 21 will be, 1.21 is greater than 1, so 1 minus 0 is 1, 2 minus 0 is 2, point 1 minus 1 is 0. So our numerator is 0.21. Similarly 1.1 minus 1 is again 1.0. So here it will be 0.1. So divided by 0.1. Now its calculation will be 0.21 can be written as 21 upon 100. Okay, which is point, after point there are 2 digits, so we can write 21 upon 100, and for denominator it is 0.1, which means 1 upon, after point there is only 1 digit, so it is 10. So it can be written as 21 upon 100 multiplied by 10 upon 1. We take reciprocal of denominator. Here 1 0 get cancelled, it will only remain 21 upon 10, which is equal to 2.1. So our calculation answer is 2.1. Okay, the value of f of 1.1 minus f of 1 divided by 1.1 minus 1, here its calculation will be 2.1. Okay, now consider the next example. The relation g is defined by g of x is equal to x square for 0 less than equal to x less than equal to 2, which means the value of x lies between 0 and 2. Okay, and 3x for value lies between 2 to 10. Okay, we have to show that g is not a function, which means that g is not functions means any of a number in between 0 to 10 has more than one images or will not have an image. That what we have to find. But here we have given x square and 3x. Okay, number are x square and 3x, and in between 0 to 2 and 2 to 10. Okay, so here for any value from 0 to 10 it will not be infinity. So because it in numerator, there is no part in a denominator. Okay, so we have to check for a boundary points only. Now here for 0 it is 0. Okay, so 0's image is 0. For 1 it is 1 square is 1, and its 1 image is 1. If we take 2, now for g of x, g of 2 is equal to, here it is lie in first interval 0 to 2 because it is less than equal to 2. So g of x for 2, x is equal to 2. G of x has two functions. G of x is equal to x square, which implies g of 2 is equal to 2 square is equal to 4. Okay, and also here it is also containing second interval also, 2 less than equal to x less than 10. Okay, so for here it is 3x, so also g of x is equal to 3x for x is equal to 2. It is also g of x is equal to 3x, which implies g of 2 is equal to 3 into 2 is 6. 3 into 2 is equal to 6. Here both are different, therefore g of 2 is not equal to g of 2 for x is equal to 2. Okay, so our, or you can say that, or 2 for x is equal to 2, we get two images in its codomain. Okay, so by definition of function, functions definition says that every domain element has an image in its codomain, only single image. But here for x is equal to 2, there are two images, so g of x is not a function. Okay, g of x is not a function. Now we have to find the domain and range of real function f defined by f of x is equal to mod of x minus 1. Okay, now we first find a domain. Domain of f will be, now if we take any real number, is there any real number or any value real numbers x, it will be a real number only. Okay, you can check it. Is there any number when we put x it will be infinity? I think it is not possible, because when you are taking real number, it is of the form decimal or integers. Okay, so for this example, mod value for any positive number, negative number or 0, it will be a real number. So domain of f will be R only. We have to observe it. By observation you can check it is a real number or you have to delete some values or not. Okay, here it is in numerator form. If it is in denominator form, if we check the value for 1 upon x mod of x minus 1, we will see that for x is equal to 1 it is 0. So 1 upon 0 is not defined. So we have to take a domain as r minus 1. Okay, for minus 1, for x is equal to minus 1 it is to minus 2, and mod of minus 2 is plus 2. It is okay for minus 1, but for 1, x is equal to 1, it will be 0. So our domain set in this type of, it will be r minus singleton 1. So in this example, it is in numerator, mod of x minus 1, it is in numerator, its denominator value does not contain x. So here domain of f will be belongs to R, and its range of f will be, so for any value, if we consider x is equal to 1, it is mod of 1 minus 1, it is 0. Okay, for x is equal to 2, it implies 2 minus 1 is equal to mod of 1 is again 1. Here mod 0 is 0. Okay, for x is equal to 3, which implies mod of 3 minus 1 is equal to 3 minus 1 is 2. is equal to 2. For negative values, for x is equal to minus 1, we get minus 1 minus 1. Mod of minus 1 minus 1 is equal to mod of minus 2, and mod of minus 2 is plus 2. X is equal to minus 3, we get mod of minus 3 minus 1 is equal to mod of minus 4 is equal to plus 4. Okay, if we see the function value f of x value is all positive, okay, for any point number, for x is equal to 0.5, 0.5, it is 0.5 minus 1, which is equal to minus 0.5. So it will be again 0.5 only, positive, which is a real number. So its range will be positive real number. Okay, R positive. So its domain is real number and its range is R positive. Okay, and its codomain set, codomain of F will be R plus only. Okay, so today we will stop here. In next lecture we will go to our next point. Thank you.